Welcome back to the deep dive. Today we're doing something a bit different, a bit of role play, actually.
Oh, really?
Yeah, usually we're just unpacking a topic for the sake of curiosity, but today the stakes are higher. I want you, the listener, and you across the table for me to imagine we are sitting in the lobby of a major tech firm.
Okay, I'm picturing the glass walls.
Exactly, the
Yeah.
cold brew on tap. And we are exactly 5 minutes away from a high-stakes interview for an AI-adjacent role.
Right. So maybe a product manager for a new LLM tool or a machine learning engineer.
Or honestly, even just a strategy role where you really can't afford to look like a dinosaur in the boardroom.
So we need to move way past the whole AI is magic phase and get into the actual mechanics of how it works.
Exactly. I've got a list right here. 12 specific, must-know questions. And this isn't just me guessing. We pulled these insights from a stack of technical glossaries, academic papers, including the famous Attention is All You Need paper, and some heavy industry reports on LLM architectures from places like AWS and IBM.
That's a solid stack of sources.
Yeah, so my job today is to be the eager, maybe slightly nervous candidate who needs some prep. Your job is to be the hire manager or the technical coach. Break down the answers for me. Tell me the why and the how, not just the dictionary definition.
I like it. We're aiming for intuition. Let's see if you're hired.
All right, let's start at ground zero. Question one. I walk in, I shake your hand, and you ask me, what is generative AI? And I say, it's AI that creates stuff.
And I politely thank you for your time and show you the door.
Ouch. Okay, fix it for me. What's the real answer?
Saying it creates stuff is just the outcome. If you want to nail this, you need to talk about patterns. Generative AI is a subfield of artificial intelligence that uses generative models to create entirely new content.
Like text, images, audio, code.
Right. But the key mechanism, and this comes straight from those technical glossaries we reviewed, is that it learns the underlying patterns and structures of the training data to generate novel outputs. It doesn't just analyze existing data.
Okay, so it's not a collage. It's not just, cutting and pasting bits of the internet together.
No, and that is a critical distinction to make in an interview. It is learning a probability distribution. If you show it 1,000,000 pictures of a cat, it doesn't store a JPEG of a cat.
It learns what makes a cat a cat.
Mathematically, yes.
Mm.
It learns the probability of a pixel being white versus black, even the pixels around it, to form the concept of a cat.
So it builds a recipe, it doesn't store the meal.
Exactly. That's a great way to put it.
Okay, that actually leads perfectly into question two, which I feel is a bit of a gotcha question. How does GenAI differ from discriminative modeling? Because, we've had AI for years, right?
Right. Netflix recommending a movie is AI. Your email spam filter is AI. Those are discriminative models.
So what's the difference?
Think of a discriminative model as an inspector. Its entire job is to draw a boundary between classes. You give it data, and it classifies or predicts labels.
Like, is this a cat or a dog?
Exactly. Is this email spam or not spam? It maps the border. A generative model, on the other hand, doesn't care about the border. It cares about the territory itself.
Because it has to build the territory.
Right. It's trained to approximate the data distribution itself to produce new data points. It wants to know everything about what a cat looks like so it can draw you a brand new picture of a cat.
So discriminative is the art critic recognizing a painting, and generative is the artist painting a new one.
That's the aha moment. One discriminates, separates, and the other approximates to create.
Okay, I'm feeling a bit more confident. Let's get technical. Question three. What architecture underpins modern large language models?
If you don't say the transformer, the interview is over before it begins.
Right, the transformer. Introduced in that 2017 Google paper, attention is all you need. But here is where I usually stumble. I know it's better than what we had before, but why?
Well, the old way was primarily recurrent neural networks, or RNNs. Imagine trying to read a whole page of a book through a tiny straw.
You see one word, then the next word, then the next.
Exactly. You process sequence data sequentially, which is incredibly slow. And worse, RNNs have terrible memory. By the time it gets to the end of a paragraph, it has mathematically forgotten the subject of the first sentence.
So how did the transformer fix that? Did it just get a bigger straw?
It threw the straw away. The transformer processes sequence data in parallel. It looks at the whole page at once. But the real magic, the core of the architecture, is the self-attention mechanism.
Break that down for me.
It allows the model to weigh the importance of different words in a sentence, regardless of their distance from each other. In the architecture, you have these encoder and decoder stacks, and for every word, it generates a query, a key, and a value vector.
Okay, you lost me a bit. Query, key, Value.
Think of it like a filing system. Let's take the word bank. In a sentence, the word bank acts as a query. It shouts out to every other word in the sentence, hey, are you related to me?
And the other words have the keys.
Yes. So if the sentence is, I sat on the riverbank, the word river checks its key and shouts back, yes, I am highly relevant to you.
Oh, I see. So the model pays attention to river, and it knows bank means the side of the water, not a place with ATMs.
Exactly. And it does this calculation for every single word against every other word simultaneously. It's very compute heavy, but it means context is preserved perfectly.
That makes total sense. Okay, let's pivot. We've talked about text, but before ChatGPT, we had those wild, sort of trippy AI images, which brings up question 4. What are generative adversarial networks, or GANs?
The GAN. This is a generative modeling technique that involves two neural networks locked in a literal competition.
The IBM sources describe this as a counterfeiter versus the police, right?
That's the perfect analogy.
Yeah.
You have two players in this minimax game. The generator is the counterfeiter. It creates synthetic data fake images trying to fool the system.
And the discriminator is the police.
Right. The discriminator looks at real authentic data and the fake data and tries to spot the forgery. And they just train against each other over and over.
Until the counterfeiter gets so good, the police can't tell the difference.
Exactly. The generator improves until the synthetic data is statistically indistinguishable from the real thing.
Which sounds flawless, but I feel like nobody uses GANs for the new high-end image generators anymore. Why is that?
Because they are notoriously unstable to train. We'll get to what replaced them in a minute, but first, let's talk about when models fail.
Oh, the danger zone. Question 5. What is a hallucination?
This is the phenomenon where an AI generates false or inaccurate information, but presents it with absolute, unwavering confidence.
It sounds like half the people I argue with on the internet, but why does it do that? Is it a bug in the code?
Not at all. It's a fundamental feature of probabilistic generation. You have to remember, the model is not checking a database of facts. It is simply predicting the next token based on probability.
So if I ask it for a legal precedent, it's not looking up a law book.
No, it's just generating text that sounds exactly like a legal brief. And if the highest probability next word forms a fake court case, it will just invent a fake court case.
Which is a massive safety and reliability risk. Lawyers have actually been sanctioned for citing cases that ChatGPT just made up.
Exactly. It's a huge issue.
Okay, question 6. Define multimodal generative systems.
Multimodal systems are models capable of processing and generating multiple types of data or modalities simultaneously.
It's not just text in, text out.
Right. Think text to video or image to audio. Or a model where you upload a photo of a broken refrigerator and ask it, what's wrong with this?
The Mistral Large 3 report talked about this. It's not just using a separate tool to look at the image, right?
Right. The new standard is native understanding. The vision encoders are fused directly into the model's architecture. It doesn't translate the image into text first. It mathematically understands the image alongside the text.
So that's wild. Okay, back to the bad behavior. We talked about hallucinations. Question 7 is about how we fix models that are, well, behaving badly. What is RLHF?
Reinforcement learning from human feedback. This is the secret sauce. It's a fine-tuning phase used after the initial training of a model.
Because the initial model is just a raw text predictor, right?
Exactly. A raw base model might be toxic or unhelpful, or just output endless repetitive code. RLHF is how we align the model with human preferences.
And what are those preferences? What's the goal?
The industry standard is the Triple H. We want models to be truthful, useful, and harmless. Or at least less harmful.
So humans actually sit there and rate the answers.
Yes, they rank outputs, which trains a separate reward model, which then automatically punishes or rewards the main AI to steer its behavior toward being a helpful assistant.
Okay, we teased this earlier. Question 8. If GANs are the old way to make images, what's the new way? What are diffusion models?
Diffusion models are the engine behind things like Stable Diffusion. They are primarily used for high-quality image generation, and the mechanics are entirely different from GANs.
The open review papers talk about a forward and reverse process. How does that work?
Think of the forward process as controlled destruction. You take a pristine image of a dog, and you gradually add Gaussian noise to it.
Just static.
Yeah, pixel by pixel, step by step, until the image is nothing but pure, random static TV snow.
Okay, why would you do that?
Because then you train the neural network on the reverse process. You show it pure static and say, denoise this. The model learns to systematically subtract the noise to reveal a coherent image.
Oh, I get it. It's like when you're looking at clouds and you see a shape that kind of looks like a dog, and your brain just sort of fills in the details until it's clearly a dog.
That's a great analogy. It learns to reverse the entropy.
Fascinating. All right, question 9. This is on almost every job description right now. What is prompt engineering? And please tell me it's more than just typing a polite question.
Way more. Prompt engineering is the practice of carefully crafting instructions or inputs to guide the AI toward a very specific desired output.
Because it's a probabilistic machine.
Exactly. You are manipulating its probabilistic generation. It's about providing the right context, setting strict constraints, and giving format instructions. You're narrowing the mathematical universe of possible answers down to the exact one you need.
Okay, we're in the home stretch. Question 10. This sounds like a legal nightmare.
Hmm.
What is training data memorization?
It is a legal nightmare. Memorization is the phenomenon where a generative model reproduces exact or near exact copies of its training examples.
Wait, I thought you said earlier that it doesn't store a JPEG of a cat, that it just learns patterns.
In general, yes. But models also have associative memory. If a specific data point is repeated enough in the training data, or if it has a very unique structural weight, the model can overfit.
Meaning if I prompt it with the first few words of a copyrighted book,
It might just spit out the next 3 pages verbatim.
and suddenly you have a massive copyright infringement lawsuit on your hands.
Exactly. The generative AI training and copyright law source we looked at highlighted this as a massive concern. It challenges the whole defense that models only learn abstract ideas.
Wow. Okay, question 11. We know models hallucinate. We know their training data gets outdated the second they finish training. How do we fix that in an enterprise setting? What is RG?
Retrieval augmented generation. RG is the enterprise savior right now. It solves both the hallucination problem and the outdated information problem by giving the model an open book test. With RAG, the model references an authoritative external knowledge base before it generates its answer.
Walk me through the mechanics of that. I asked the chatbot a question about my company's HR policy. What happens?
Behind the scenes, the system uses a vector database to perform a relevancy search. It turns your question into math, finds the company documents that match that math, retrieves the specific HR policy, and feeds it to the LM.
And says use the specific document to answer the user.
Exactly. So the response is accurate, it's up to date, and most importantly, it can be cited. It's not just relying on its frozen internal training weights.
That is huge for businesses. All right, final question, number 12. We talked about GANs and diffusion models for images. There's a third one that pops up in these technical glossaries. What is a variational autoencoder, or a VAE?
The VAE. This is a deep learning model that probabilistically encodes data into what we call a latent space and then decodes it to reconstruct the input.
Latent space. That sounds like something out of Star Trek. What does that actually mean?
Think of latent space as a compressed mathematical map of the data. What makes a VAE special is that it models this data as a smooth, continuous probability distribution.
Smooth as opposed to what?
Well, with a GAN, the latent space can be very fragmented. If you try to mathematically transition from a picture of an apple to a picture of an orange, a GAN might give you complete garbage in the middle.
But a VAE wouldn't.
Right. Because a VAE forces that space to be smooth, you can generate smooth variations or interpolations between data points. It's also incredibly useful for anomaly detection.
So if you're looking for subtle manufacturing defects on an assembly line, a VAE might be your best friend.
Exactly.
All right, that's 12 questions. We covered the basics, discriminative versus generative. We went through the architectures, transformers, GANs, diffusion, VAEs. We hit the pitfalls like hallucinations and memorization, and the fixes like RLHF and RAG.
If you can articulate all of that with the intuition we just discussed, you're definitely acing that interview.
I feel a lot better, but I want to leave the listener with one final thought, something to chew on after the interview is over. Through all these sources, we talked a lot about the math, the vectors, the matrices, but there's this underlying issue called the black box problem.
Yeah, that is the elephant in the room.
Right, because we build these models, we set up the architecture, we feed them the data, we do the math, but once a model has hundreds of billions of parameters, the specific, intricate decision-making process inside that massive neural network, it remains incredibly difficult to interpret.
We know what goes in and we know what comes out, but mapping the exact path in between is still largely a mystery.
Which is wild when you think about how heavily we're starting to rely on them. Figuring out that black box, that is the next great challenge for AI professionals.
For sure. Mechanistic interpretability.
Exactly. Well, listener, go crush that interview. Remember, it's about understanding the why and the how, not just memorizing the definitions. Thanks for joining us on this deep dive.
Catch you next time.
If you enjoyed this video, please subscribe and support the channel. More exciting AI questions and insights are coming soon.